So this is problem 38 of chapter 19 of Giancolin 6th edition. So we have 3 capacitors in this circuit, and we are given this 26 volts that is across this circuit, now applied across the whole network. And we want to know what is the voltage across each one of these capacitors. For the first capacitor, this capacitor of 2 microfarad here, it's trivial to find this voltage, right? Because this is the full voltage that is applied in the whole network, right? We go from here to here. This is the same point as these two. So for these 2 microfarad, we just have 26 volts. Don't have to think much more about this. How about the other 2? So we also want to know the voltage across this 3 microfarad capacitor and this 4. And there we're in trouble because we don't know how this potential difference is distributed among the 2. We just know that from here to here we have this 26 volts. But let's think, how do we find voltage when we are dealing with capacitors? We need to apply this equation. Q is CV. So if we know the charge that goes through capacitor 3 and the capacitor 4, then we will know how to get their potential difference, right? So we can obtain the potential difference of each one if we know their charge, and the capacitance we already know. Okay, so let's try to find what is missing in this story, which is this charge. Now, to get this charge, remember that these 2 capacitors are in series, so the charge that is in one capacitor has to be the charge in the other one, otherwise we wouldn't have found this equilibrium point. Now, if we didn't have the same charge for 3 and 4, the charge would still be moving. Okay, so we know that the charge for the capacitor 3 microfarad is equal to the charge for the capacitor 4 microfarad. Okay, and how are we going to find this charge, which is the total charge for this line in series? Well, then we can resort to finding the equivalent capacitance for this series part. And how are we going to do that? Remember that equivalent capacitance in series is 1 over. No? So 1 over the equivalent capacitance is equal to 1 over the capacitance for the 3 microfarad capacitor, 1 over the one with 4 microfarad capacitance, right? So using this expression, 1 over CEQ is equal to 1 over 3 10 to minus 6 Faraday plus 1 over 4 10 to minus 6 Faraday. We are going to find, well, if we just solve this expression and then invert to get the equivalent capacitance, we are going to find something as 1.714 10 to minus 6 Faraday. With that, we can then find the total charge, right? We just use this expression, Q is equal to CV, and we find this total charge. So let me erase this. So we just found this equivalent capacitance, so we put it here. The voltage, as we said, the voltage across both capacitors is the total voltage of the circuit. So from here we find this total charge. With this total charge, we can then come to this expression here to find the voltage of each capacitor. So with this total charge, we come up here, we divide this total charge by the capacitance. So in this case it's 3 10 to minus 6, and in the other case we divide this total charge by 4 10 to minus 6, and we'll find the voltage across each one of these capacitors.